Okay, we've just reviewed this entity relationship model and built an ERD diagram in Word, so sort of a rough drawing. Now remember, these are the entities that are within a database. So there are students in this case, there are schools in this case, vehicles, parts, manufacturing locations, and models in this case. Remember, the relationships are one-to-one, one-to-many, and many-to-many. Now, when there's a many-to-many situation like we used, or like we identified within inventory, orders to items, then we have to put an associative entity in the middle. So right in the middle between the two orders and items tables. Okay, now with that said, we'll go on and take a look at this. This is typically what a relational database looks like, and this is a Clearwater Traders database that we'll use throughout the course. Now, with this we'll see tables, customer, orders, and order line, and inventory, color. So we'll see all of these things, all of these tables, and these are all the pieces that go together to make that database. Now, we have to know all of these separate entities, customers and orders and inventory and items, in order to be able to build this database. Now, when we go on and talk about this a little bit more, we'll talk about a lot of this in class. Fields, primary keys are probably the primary keys and foreign keys are the most important. Primary keys are a column in a relational database table whose value must be unique for each row. It uniquely identifies that particular row of information. So think about your address, your address, and all the information about you, for instance. Now, a foreign key is a column or columns in a table that match the primary key in another table within that same data store or within that same database. Okay, so the primary key ties to the foreign key and ties this table to this table. Now, a composite key, which we'll look at a little bit, is a unique key that is created by combining two more columns. So you have one table, the first table, the second table, and then if you have to have that associative entity in the middle, then you have to tie in the primary key to a foreign key, primary to a foreign. You put those two foreign keys together and you can create a primary key. That's composite. We'll take a look at that in more detail on in class. Now, what we end up with these primary keys and foreign keys, this is what this database actually ends up looking like. You have a primary key tied to a foreign key, primary key tied to a foreign key, a primary tied to a foreign key. This is that composite primary key. These are two foreign keys. You have to identify these as foreign keys, but then you can identify them as a primary key. Okay, now, and again, this points out that this situation here is the very same way. Order line, OID, and INV-ID is a composite key. They're two foreign keys. And shipment line, ship ID, and INV-ID are both foreign keys from other tables. Foreign keys that are primary keys in other tables. That's the best way to say that. You put them together, it's a composite key. Now, normalization. Normalization is the process of efficiently organizing data in a database. So there are two goals to this: eliminating redundant data and ensuring data dependencies make sense. So we had looked back at this big old can. Maybe I probably have a big old can right there. So here's a big old can of data. It's unnormalized data. You have SID, SLAST, you have courses, you have credits, you have grades, you have faculty stuff, you have all this stuff in one big can. Now what we want to do is take this all apart so it looks more like this. Okay, now so we'll go on here. There's some, first of all, we'll see that there's some repeating groups. For instance, Jones took a database course. Jones also took Intro to Java. And with that, the instructor for the database course is Marx, and Julen is the instructor for Intro to Java. Okay, now shouldn't this be a political science class? Just a thought. Now, possible primary keys. We're looking at first normal form. We have to identify the primary keys. So repeating groups are removed and the primary keys are identified. So we have to make records of each one of these rows, records of each one of these rows, even if there are repeating datas. So SID is probably going to be a primary key for student. Course number is probably a primary key for course name. FID is probably a primary key for FLAST. That's what we do with this first normal form. Second normal form, we start to reduce the amount of redundant data in a table by extracting it. So anything that looks common within the first normal form will now be taken apart in the second normal form. And we can see that we're doing this. So the student table, we're pulling all the student information out, and then the primary key will probably be SID. Okay, and that's this new student table, what the new student table looks like. Now, for the course table, this is all the course information that we had. To pull that up, and I guess the other part is this. Let me step back. So what we have here, the redundancy, the data redundancy piece. Remember that in our first normal form, we had repeating groups, Jones and Jones. Second normal form, we see this. We see that this is what we have originally, Jones and Jones. What we do is reduce the redundancy. Jones only has to be entered once. Marsh only has to be entered once. We add a primary key. The same thing happens with the course table. We have database management course here. We have computer apps. All we need and all we really have are 4 courses. So we're going to reduce the redundancy and pull out redundant data and simply make database management, enter the Java, info systems, and computer apps. Okay, we only have 4 courses. To continue on with that thought, where are we at? There we are. Grades. Okay, so we have SID and we have the course number and the grade. So now we end up with a grade for a table with a grade, and then we're going to call this a grades table. And you have an SID, the student ID, and the course number. So doesn't a single student, and one specific course number, doesn't that make a unique primary key? You can only think about yourself. A spring semester, going back to spring semester. So you and that course number and probably that spring semester will be unique. So you tie all these 3, they're actually primary keys in another table, they're foreign keys in this table, and you put those together to make something unique. And then you associate the grade with that. Jones got, databases, got a C in databases, and got a B in computer apps or whatever it was. Faculty, same idea. You reduce the amount of data. You only have Marks, Langley, Brown, and Zulin, and the original unnormalized data form looked like this. So what we end up with then is this relationship between student, course, grades, and faculty, and that SID is tied to SID and grades. In the course table, course number is tied to the course number and grades. FID is tied to the faculty table. With these relationships now, you can search any part of this database and put all the information together. This is that second normal form. Now, there's a third normal form and actually a fourth and a fifth, and so on. But we're just going to go this far. And probably in most cases, you'll only go to the second normal form anyway because our databases are small enough in our course that we just won't need to go on beyond that. Now, the third normal form removes columns that are not fully dependent upon the primary key. So, in this case, in this course table, for instance, you have course name, or course number, course name, course enrollment, and credits. Now, ask yourself, is course enrollment fully dependent upon the course number? No, not at all. The course number, well, it depends upon the semester. It depends upon the semester most specifically. So, what's the course enrollment for the spring database management course? What's the course enrollment for the fall or the summer database course? So course enrollment is not fully dependent upon course number. Now, what you have to end up doing with that then is going to taking the course table apart and put it into 2 more tables. You have a course table, which provides or gives you the course number, the course name, and the credits. The credits will always be the same regardless, right? But you also have to have an enrollment table. So you'll probably have the course number and the semester, and what is the enrollment for that particular semester, that course in that particular semester. Again, you have some composite keys, you have some primary keys, some different things like that. So what you'll end up with then is the first normal form, which looks something like that. The second will end up looking like this, and the third, if there are any fields that are not fully dependent upon the information within the table, then you go ahead and take those apart and create another table. So that is basically the normalization. It's called data normalization process, and when you develop this, you'll probably be creating. Let's see, in Notepad++. Let's see what I have here. I had some whole bunch of database stuff out in that. Let's go to a new one. So what you're probably going to see with normalization is you're going to type in customer. Let's not even go there yet. I'll do this in class. Okay, so I'm just going to outline what you might see. All right, so with that said, that'll cover data normalization. Thank you.